So this problem gives you some of the names of some simple organic alcohols and thiols, and you're just asked to draw the structure of these compounds. So let's start with a simple example, 1-methyl-cyclohexanol. So anytime you are given a name and you're asked to draw the structure, just start with the parent name, which is in the second part of the last part of the name. So cyclohexanol is going to be a 6-membered ring, and whichever carbon has the OH in the cyclic structure is going to be the first carbon, because alcohol takes priority. And then you have 1-methyl-cyclohexanol. So this is carbon 1. Then that also is going to have a CH3. That is 1-methyl-cyclohexanol. And let's say para-bromophenol. So which means first draw the phenol. And in the para position you have a bromine. And cis 2-methyl-cyclopentanol, so which means you have to draw a cyclopentanol, and the carbon with the OH is going to have locant 1, and which means on the second carbon you're going to have a methyl group. And as you know, when you have a cyclic structure, you're going to have a plane for the molecule in which all the 5 carbons are going to be in for this planar structure. That means if it's cis, then both the groups are going to be on the same side of the plane. Therefore your methyl group is going to be the same side as the OHs compared to the 5 carbons which is in the same plane. So that is what cis and trans has to be. So remember, whenever you have a cyclic structure, you have to remember whether or not these two groups are in the same side or on the opposite side, and based on that you're going to give a cis or a trans designation prefix. And let's look at G. So this is butane thiol, which means you're going to draw a 4-carbon structure, which is butane. And you can start drawing any structure and then find out whether it's R or S, and then switch it if needed. So for example, on the second carbon you're supposed to have the thiol group, so I'm going to have a solid wedge and put an SH group over there. So that is butane thiol, and that's the second carbon, so that's 2-butane thiol, or butane 2-thiol. Both are equally correct, but just make sure you have the right stereochemistry. So 1, 2 and 3, that is clockwise, which means this is an R. Therefore I have to switch any one group, and I would rather switch this group here, which is easy to do because I can just draw a broken wedge. And now that the hydrogen is projected towards you and the SH is projected away, this is going to be the S molecule. So 1, 2 and 3 clockwise with the 4th priority group projected towards you. That means this is an S structure. 2-cyclohexanol, hexenol I mean, sorry. So which means you're going to have a cyclohexene, and then on the second carbon you have your alkene. Therefore the alcohol is going to be the first carbon, and the second carbon is going to be the alkene, because alkene takes second priority, alcohol takes first priority. So that cyclohexanol, if it's an alkene, it's a cyclohexenol, and the OH group is on the first carbon atom, and that means the alkene has to be the second carbon atom. So that is 2-cyclohexenol. And let's look at this, 2-methyl 2-propene 1-ol. So propene 1-ol means you have a 3-carbon chain, and then you have on the first carbon an OH. That's what the 1-ol means, and it's 2-propenol, so which means carbon 1, carbon 2. On the second carbon you have the alkene bond, that's the propene part. So 2-propene is, this is 1, 2 and 3, 2-propene. And on the second carbon you have a methyl group, so you're going to have a CH3 over here. So that is 2-methyl 2-propenol. And since these two hydrogens are the same, there is no cis or trans that needs to be specified in this case, because this structure or this alkene cannot have cis and trans. Okay, so that is your 2-methyl 2-propenol. And now we will look at giving names to the structures that are shown here. So this is an alkene, and it also has an alcohol. So which means this is 1, 2, 3, 4 carbon chains. So I'm going to draw a 4-carbon chain. you have CH3, CH, C, C, and then an OH, and that carbon should be carbon 1. We are going to give this carbon 1 because it has the OH, which takes precedence over the alkene group in terms of the locant, or the lowest possible number you can give. That is 1, and then on the second carbon you have a double bond, so that's carbon 1, carbon 2 has a double bond. And let's say if this is a trans structure, as you can see here, then you have to give a trans designation. If it's a cis, it has to be a cis. This structure, this structure does not have any information about whether it's a trans or cis. So if it's given in the condensed form, you don't have to worry about giving it the trans or cis prefix, but if it is given in the skeletal form, you have to. So I'm just starting with the skeletal structure so it's easy for you to see, and I will name this. So that is butenol, and it's going to be 2-butenol, 2-butene, 1-ol, because it's hydroxy on the first carbon, and this is going to be a trans molecule. If this is the skeletal structure that was given. If they did not give you the skeletal structure and you're simply given this structure, then you're not going to even say trans or cis. It's just going to be 2-butene, 1-ol. And obviously the cis is going to look like this, because the two identical groups are on the same side. So this is going to be cis, the same name. Okay. Alright, so that's the question G. And this question has a 3D representation of the molecule in the ball and stick model. That is 1, 2, 3, 4. So we have 4 carbon chain. On the second carbon we have a thiol. So I will draw it the same way it is there, because we will have to worry about its stereochemistry. So that's how it is. That's a CH3, and this sulfur is shown in a way that it is projected towards you, and the hydrogen is actually going below like that, which is going or projected away from you, and that's the ethyl group. So this is 1, this is 2, that is third priority, fourth priority. So this is a counterclockwise rotation, so it's an S molecule, and this is 1, 2, 3, 4, it's a butane thiol, or you can also say 2-butane thiol. Both are equally correct. And you have to say whether it's an S or an R. In this case we just found out it's an S. So that is the name of your molecule. And so this problem has 1, 2, 3, 4, 4 carbons. On the second carbon you have an OH. That's what this is. So this is also 2-butanol, or butane-2-ol, butan-2-ol, not butane, butan-2-ol. So here this is 1, that is 2, that is 3, but this is a chirality center, but you don't really have information about the chirality center, whether it's an R or an S in this given structure. Therefore this is the only name you can give. But if the skeletal structure was given and the skeletal structure had the stereochemistry information like that, then you'll have to say that this is an R molecule, right? If this is the structure that was given, you will say it's an R, 2-butanol. If this is not given, if this is the structure it's given, it's simply going to be 2-butanol. And finally we have a molecule which contains a bromine and an alcoholic group. So this has a CH3CHBr, a carbon, and then 3 CH2s and an OH. Alright, so here's a carbon, which is that carbon. I'm going to start there. I'll tell you why it is. Because you have 2 CH3s, which means this carbon has a CH3 here, a CH3 there. That's what that CH3 twice is. And then you have an OH, and then you have a CH3, CH, CH3, and this carbon also has a bromine. That is what this expanded form is. So we have to make sure that we find the longest chain. So the longest chain is going to be 1, 2, 3, 4, or 1, 2, 3, 4. They're both equally long, and you should give the smallest possible number for your carbon with the OH. And again, it doesn't matter whether you start on the methyl here or the methyl here. it's going to give the hydroxy group containing carbon the same locant number. Therefore, we're going to call this 1, 2, 3, and 4. And even though bromine is there, we have to make sure that alcohol gets the smallest possible number. Therefore, this is going to be a 2-butanol, right? This is going to be a 2-butanol. So 2-butanol. And on the third carbon we have bromine, so this is going to be 3-bromo 2-butanol. Okay, 3-bromo 2-butanol.